Alright guys, so here we are doing hypothesis testing. So this is hypothesis testing, example number 4. Now imagine that you work for a dealership and you want to know, and you know that the population average amount of cars per week that you sell is 60. Now you decided to spend some money on advertising and you took a sample of 12 weeks and it gave you a sample mean of 70 and a standard deviation of 10. Now you want to know if there's been an increase in the number of cars sold. Oh, give me a second here. Alright. Alright, so, and you want to know if there's been an increase in the number of cars sold. Okay? So we got to go through the 5 steps of hypothesis testing. So step number 1, we need to create our HO and our H1. Alright, now for our HO, our null hypothesis, now the way we figured this out, by the way, is by kind of looking at the question. So the question in this case says, has there been an increase? Because it's asking you for an increase, then we know that we need to be creating a one-tailed test. So we're going to put here mu greater than 60. And we're using 60 again because that's the mean center of the data, population. And then we're going to do HO less than or equal to 60. Alright? And now we set up our step 1 for hypothesis testing. For step 2, we need to figure out our significant value or our alpha. Now the alpha, again, in real life you can select any alpha you want. In the case of an exam, a professor has to give you an alpha, because otherwise everybody will be conducting a different test. Now for step number 3, we need to figure out which test we're going to be conducting. Now a lot of the examples that I've been doing are basically based on normality, so we're going to assume a normal distribution. And then after that, you need to figure out whether you have been given sigma or you have not been given sigma. So whether you've been given the population standard deviation or you have not been given the population standard deviation. Now, if you know, in this case, we don't know our population standard deviation. Notice that you get your population mean, but you don't have a population standard deviation. So, if we don't know our population standard deviation, we need to use a t-test. So we're going to use t equal to x bar minus mu over s divided by square root of n. And in order to conduct this particular procedure, we got to use degrees of freedom of n minus 1. Alright, then we go to step number 4. Now in step number 4, I like to draw the graph. And again, I draw the graph so that you kind of you can figure out what's going on. Once you figure out how to do this, you don't really need to draw the graph anymore. Alright, so because we've set up H1 as greater than 60, then we need to create a critical value here for our rejection area. We need to find our critical value. Now our critical value depends on this alpha that we selected up here. So we need to create an area for HO, and then we need to create an area for H1. Okay? Now to find this critical value here, we use our table. Now remember, you got to be using the student t distribution table. Looks like that. Okay? Student t distribution. Then we're going to be looking over here where it says level of significance one-tailed test, and we're going to be using alpha 0.05. So we go for level of significance one-tailed test 0.05, that's the second column. And then we have a sample of 12 weeks, but we need to use degrees of freedom of n minus 1. So that means that on the side where it says degrees of freedom, we're going to be using 11 because n is 12 and then n minus 1 is 11. So we're going to be looking for 11, and we have our second column, which is the level of significance one-tailed test. So the critical value is at 1.796. 1.796. Okay. Now once we have our critical value, we conduct our test. And we conduct the test by basically plugging in the numbers and getting a t. So in this case, t is going to be equal to x bar is 70 minus mu is 60 divided by s is 10, and that divided by square root of n, which is 12. Okay, let's plug in this into my trusty calculator. And I got 3.46. Alright, now this 3.46, notice that is greater than that 1.796. So this number will be over here because 0 is the center. Alright, and then that number is to the right of this. Because this number is to the right and in our rejection area, and notice that it falls on H1, for step number 5, we're going to say we reject HO. Now rejecting HO means that there is a difference. So if you go back to the question was, you want to know if there has been an increase in the number of cars sold. And the answer is yes. There is a significant increase in the number of cars sold according to our hypothesis test. So your manager should be happy in this case that the advertising campaign seems to have increased the amount of cars sold. Alright, hopefully you like my example for hypothesis testing. Have a good one.